By the year 2035, General Motors plans to offer only electric vehicles, and Ford is beginning to set similar goals. Can you imagine that? The gas-powered car that you likely drive now will not even be offered by two of the largest producers of automobiles in the US in just 14 years. But is our battery technology really ready for that? Hi, I'm Spencer Dahl, and I'm a PhD student here at UC Davis in the chemical engineering department. And I study what keeps making batteries fail. Why can current electric vehicles only go a few hundred miles? And why does your phone battery always die in the middle of the day? Basically, I'm here to make sure you can stop recharging your phone multiple times a day because it keeps dying from you watching YouTube and TikTok videos. So why are batteries so important? Well, batteries have become very portable over the past few decades, and specifically lithium-ion batteries are already in a number of electronics, like the phone batteries shown on the slide in the newer electric vehicles. But batteries are also a popular energy storage technique for the future, as renewable energies like wind turbines become more efficient and even more widespread. However, we currently have no way to store all that energy that gets produced when it's windy outside. And the reason we can't store that energy is because of all the problems with lithium-ion batteries. So when it's not windy outside, we can't utilize any of that energy that was previously produced. So why can't the battery store that energy? Well, a lithium-ion battery operates by moving the red lithium atoms, shown in the figure, between the positive and negative ends of the battery, which creates a flow of negatively charged particles known as electrons that can power your phone or car. But as this lithium moves from one side to the other, it can create weak points in the structure that allow it to collapse. You can draw some comparisons of the structure of a battery by looking at the wood frame of a house. So a house is made up of wood studs that support the structure. But if you were to remove a few studs in an area of the house, you might see the house sag or even collapse on itself. Similarly, in a battery, the lithium acts as the studs for the structure. As you begin to remove those lithium studs, the structure can collapse and not allow the lithium to come back in when the battery is being recharged. Now, my research focuses on solving this problem and making that structure stronger. So I go into the house and I replace a few of the studs with ones with different materials and see how the strength of the house changes. So just as cartoon character Spencer's doing, I can go into the structure of a battery and replace a few atoms with ones that are larger or smaller or have a different chemical makeup and see how the strength of the structure changes. For example, in my research, I've seen promising results of making the structure stronger by replacing a few of the cobalt atoms in the positive end of the battery with ones like tin and titanium. This research could mean we could fundamentally understand why batteries fail and also how to successfully prevent that in the future. It can mean we could actually reach our goals for climate change, renewable energies that are being set by GM and these other companies, all while keeping your phone charged for those TikTok videos. Thank you.